Hey, okay, welcome back, everybody. We're going to be talking about CanView bindings and CanView stash and how they work and do kind of a code review of them. Everybody at Bitovi who's here, please don't hesitate to ask me questions at any point. So when I talk about CanView bindings, I mean all the former CanClick stuff. So how this event and method gets called, or the click method gets listened for, and the method gets called, and also and the new version of event bindings and beta bindings, which look like this. So if I wanted to two-way bind an input's value to someone's name, I would do it like that. So this is what I'm talking about with bindings. So all of this happens in bindings.js, and the way that I think of it is there's kind of two parts of bindings. Kind of where it all starts is where all of the custom tags are set up. So this is where CanView custom attributes. So CanView has an attribute method that lets you listen to when a custom attribute when any attribute matches a certain pattern, and allows you to call a function. So here is where really the kind of the main entry points of different custom attributes are linked up. So this is for a data binding, and you can see here it kind of looks like what a data binding is, and then it calls behaviors.data. For the reference, it's called behaviors.reference. For the event binding, behaviors.event. Here's a recently added, this is by Prashant, one of our new contributors. He added the ability to, if you have mismatched parentheses or something that kind of looks like a binding but isn't right, it'll give you a warning now, which is nice. And then here's kind of some of the legacy CAN event bindings and CAN value bindings are hooked up. So this is where things really get started, but all of these functions need to be defined before they can really be used. So they're all defined on this behaviors object. And this is the first thing that's listed here.
Just the legacy two-way syntax is not defined here, right?
No, it's not listened for. So that's a really good point. So previously, and what still kind of happens is previously a lot of the data bindings code was in CAN component, and the legacy binding code was in there, obviously. And now what I've done is I've moved all of the binding behavior into this file. But CAN component calls something. So let me try to make this clear. So most of the binding syntaxes, or a lot of them, like CAN event, or sorry, the new click event binding syntax, or things like that, it's wired up by the essentially stash or mustache, seeing that there's an attribute someone's added that matches one of these regular expressions, and then sets it up to call this callback function. There's one exception to this, which is what components do. And components set up all their bindings at once. So it's not like individual attributes are matched. So it's not like where's the data binding? So here's the new data binding syntax. If you have a component, you have the data binding syntax, or any binding syntax in a component. This, hold on a second, I might put on some headphones real quick. Can you guys hear me?
Yep.
Okay, cool. There's a kind of an exception to this. So component, this attribute is going to be matched, but it's actually going to kind of be ignored, and we'll see that in a moment. That when this attribute is matched and it tries to call behaviors data, there's actually a little signal that component sets on this function that says, hey, don't do any event binding because I'm going to manage calling all of the event. Can component will go through every one of its own attributes and set up event binding. And the reason for that is really because it wants to create its view model as not just a plain can map, but as an instance of something. So it needs to kind of get in there and do a little bit of setup. So we'll see that. So most of the behaviors, so there's these different behavior functions, essentially. There's not very many of them. There's data for data bindings, reference for just this short reference exporting, where you just essentially export your view model to a reference scope item. There's event bindings, and there's the old can value, and then there's both the old event bindings and the new event bindings both call behaviors event. So that's just kind of how everything's set up, and most of the work is in here. So like I mentioned before, there's data for data bindings, reference, event bindings. Can I code fold a little bit here? Let's try it. Yes, I can. Nice. So we can kind of see what they are. This is inside the bindings object. Now, the one that I didn't reference is the view model bindings, and this is what can component calls. But before we look at that, because it's a little bit more complex, let's take a look at what happens with a normal data binding. And we'll kind of walk through what happens. Essentially, any tag, anytime you register can view attr and with a function, that function gets called back with the element and this attr data object that has things like which attribute was matched and the scope at the point of that attribute. So what the data binding syntax needs to do, for the most part, is call this make data binding, and I'll show why this is kind of a separate function. It's like I didn't do it all the work in here, mostly because the view model wants to call the same method. And this method is written a little weirdly because it needs to do kind of continuation behavior, which I will hopefully explain. But what I mean by continuation, I mean data binding needs essentially what you can think of data binding as is making two computes and then getting them to update each other. And maybe I'll kind of talk through that in here. So if I had a data binding like this, essentially what is happening is a compute is being created, a parent compute, which is for the name, which you could think of it as looking something like this. And let's say I have the scope. So what this might do is return scope.name. But it's a two-way bound compute, so I can also set parent and I can read parent. So it needs to actually look more like this. So if we're setting it, then we're going to set in the scope whatever the new value is. And otherwise, we're just going to return the value. So you can think of it as there's one parent the compute that's created that represents this, and there's a child that represents the value property of the view model, which would actually be a compute very similar. Instead, it might do something like, with the view model of whatever element, it might be view model.attr instead of the scope. And what happens, for the most part, is if you're doing a two-way binding, it's going to listen on the parent for it to change, and then whatever the new value is, it's going to update the child. And the child, and if as long as it's two-way binding, you'd have the same kind of thing actually with the child. It was just in reverse. Now, we might see there's a little bit of stuff that goes inside these bindings to make sure that cycles can't happen, that it just like, the parent changed, so it sets the child, and then the child changed, so it sets the parent, and blah, 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 and like it never ends. There's stuff that prevents that, and there's also stuff that makes sure that when the element, if this element goes away, these bindings are being torn down. Now, part of the hard part, what I was talking about, is you don't always have the view model right away, but you need to be listening on the parent to be able to read the parent's value. Well, let me talk about the problem with can component and why we'll see things are a little strange inside. With can component, I want to be able to read the parent scope value and get whatever the current value is. This might be the value of name in the scope. I want to bind first, because whenever you bind to something, the value becomes cached and very quick to retrieve. And I want to initialize the view model with whatever to actually get the view model, I need to be able to do new, maybe it was a, I don't know, some component view model. I want to be able to set its value to whatever the name value was, right? Essentially, I want, for something like this, I want to initialize the component's view model with whatever the value of name is as the value property of the component view model. I'm going to let that sink in. Any questions so far? No? Stunned silence? Okay. Should I cycle back and kind of re-explain a little bit of this, or?
Yeah, I think reiterating the last bit be good.
Okay, okay, so if you have a binding like this, and this is part of a component, you can see how when the component's view model is created, you'd want the value attribute of that component, whatever property on the view model, to be whatever name is in the scope. You with me there?
Yeah.
So you definitely want to be able to do, when you create that view model, you want to have that value from the scope.
Yeah, you need all of them, right?
You need that value, right? Now, you could read that value kind of twice. The problem here is essentially you need that value, but the fastest way to you only want to read that value once if you have to. And since you're going to set up a binding on the parent, like you're going to create this parent compute anyways, and then eventually you're going to listen to when it changes and update the child. Well, the best way to get that value then is, to create this compute, bind, even before you have the view model. Like you're still going to bind, but essentially this callback function here doesn't even know about the view model yet because it hasn't been created. So essentially, what I've got here is totally fine because I'm binding child after. What I
Okay.
mean is, let's say I put this code up here, and I wanted to listen to child. Well, the view model doesn't exist at this point,
Mhm.
so this would break. So essentially, you have to do your child binding after the view model has been created always. And,
And
but
the
you do
child,
your parent before the view model is created if you want really good performance.
the child is the view model.
Child tends to be the view model, yeah.
Cool.
Okay, so we're going to kind of see all of this again. So in this make data binding callback, essentially. So this, there is a view model when you do, if someone's just found a kind of standing out in space, if you found a syntax like this, a custom attribute like this that's not on a component, it will it will still run through this function here, and it will set up view model bindings, but it won't essentially. You can think of it as can component will initialize its view model with the value in the scope, but any other type of element will not have its view model initialized. It said the view model will be created, and then later the binding comes in and updates the view model. So like can import is an example of this. Or if you created any of your own custom tags. Anyways, hopefully that kind of makes sense. Anyway, so let's go through this make data binding function, because this really does what most of the work is. Make data binding takes a name of the attribute and whatever the value of the attribute is. So the name would be a string that looks like this for the binding, and the value would be whatever is on the right-hand side. And then it takes the element the binding is on, and then it takes a bunch of information about like other auxiliary information, like what type of template is this? Is this a mustache template or a stash template? What's the scope that we can look up values in? This is the semaphore here is to make sure cycles don't happen. This is an object where we can kind of control if the parent has been updated, and then we use that to update the child, and then the child immediately changes. Well, don't update the parent because you might be part of a cycle. This essentially contains semaphore +1, -1 flags that can be added. Get view model, like I said, the view model might not be present when the parent binding happens. So we essentially say, hey, here's a function that you can call that will eventually give you the view model. Like we'll eventually have the view model when you call this at the right time. So let's see what this does. So this is where most of the real functionality happens. And okay, make data binding. Make this a little bit smaller so you can see it all. We'll go there. This for full screen? Nope. Oh, right there. Good enough. Okay. So the first thing make data binding does is calls this get binding info, and it passes it essentially the node information, the node name and node value of the attribute, and a few bit of other extra information. And what this returns is an object that tells you everything there is to know about that data binding information. So, for example,
sorry, what is the node again?
The node is like this. It can be just a normal attribute node, or it can be an object that looks like an attribute node.
Okay.
So if people don't understand what I mean by that, if you do like element.attributes, there's an array of attribute nodes. Each one of those has a name and value property. There are actual attribute nodes, just like there are text nodes and things like that. So let's look at an example of this. If I had an old mustache legacy style template and I had a foo, well, let's look at this example first. If I had an old mustache template and I had an attribute that was foo ed equals bar, so I had some old thing that was like my component and I had foo ed equals bar, well, what would the behavior of this binding be? Well, the parent place to read from is the scope, right? Read bar from the scope. The parent name is bar. The child you're reading on the view model, the child value you're reading is food, fooed. And then what kind of binding is this? Well, this is a two-way binding. So not only are you binding the parent, listening to the parent value and updating the child, you're listening on the child and updating the parent. So essentially this function is it knows whether like your stash or mustache, the new bindings or old bindings, and returns an object like this that kind of controls all the other functionality from that point forward. I'll give one more example and do it like, all right, let's do this one. Let's do, what would, let's do this. What would that do? Someone who's not Matthew or David. What would you expect this to look like?
Where on the screen are we supposed to be paying attention to right now?
Sorry, down here.
I think these pictures might be over where you're off.
Can you not see line 58?
No, there's pictures in front of you.
Okay, let me
Maybe
copy and paste it into here. Okay.
Line. Yeah.
So I'll copy that first object stuff and you can tell me what you think it will look like. So what do you think the parent will be? Parent options, there's scope. You can bind to either the scope, the view model, or an attribute.
It's probably the attribute because there is $sign.
You're right that there's a $sign, but this parent binding is bar here would be the right hand of the equal sign, right? So
sorry, yeah, it's the
yeah, so it would still be scope.
The parent is always the scope, right? The parent would never be.
Yes, it is right now, I think. I mean, there maybe in the future there's ways you can say element to. I could see a way to say I want to go from element to view model. Like I want whatever my components, you know, if it's value attribute changes, I want that to be value on the view model.
Oh wait, no, it would do that now.
There's no way of doing that right now, though. A good way of doing that, at least. Okay, so what would the child be? Ilya, you kind of had it.
So it's attribute node.
Yeah, it would be attribute. Attribute. So then, parent to child. Basically, are we updating the child when the parent changes?
That's false.
Yeah, false. Good. And then child to parent would be true because we are we are updating when the child changes here. We're going to the parent, and then everything else would be pretty much the same property names and things like that. Except actually, I take it back. But it does know that if it's an attribute or something like this, it doesn't do the camelization and gives you the foo ed. Cool. So that's what you get from this get binding info. And then we use that to say, okay, I know what kind of parent compute I want to. There's this next object which is get compute from, which is an object that has a scope, a view model, and a attribute function on it. And we can essentially, let's take a look at one of these actually. So that is going to be, we can take a look at like the scope one or the view model one. So this get compute from has different methods that all have the same call signature for the most part. There's a little difference right here, but essentially they get the element, the scope, what property to bind to on whatever, and a bunch of options object. So for instance, and they're supposed to return a compute. So the scope, if we want to compute that binds on the scope, well, nowadays with can stash, there's like, you can kind of create expressions given whatever value is here. So if people, scope prop, remember, might be something like, now you can do bindings that look like this. Foo is equal to, you can use like full stash expressions now, which is really cool actually. So if you had a method, some method that needed to be passed the current context and then like a number, and you wanted whatever this resolves to be set to foo, you can do that now, which is really, really powerful. Because if some method is reading observables and whatnot and doing like, maybe it was what you wanted it to bind to the first item or the, really the second item in some array, which was the current context, it can do stuff like that now. So you use this expression parser to parse this into an expression, and expressions always, if you want a compute for them, you call that value, that'll return you a compute, and you pass it the scope, and this is really the helper scope. This really could be options now, which would be better. And this returns a compute given the scope. For the view model, it's a little trickier because we might not have a view model yet. That's why we have that options get view model, which reads the view model. If we're setting the view model, it sets it. Otherwise, it uses can compute read, which is a little bit smarter way of reading values than just using .attr. And then attributes, this is to create a compute given, remember this will be something like the property or the like value property or some attribute name. What it does is a little bit more complex. Essentially what it does is it creates its own compute with this kind of syntax with a compute where you can kind of control the how do you listen to things and then how do you read the value and update the value. And it has to do a lot of work to make things like selects two-way bind correctly. So there's all this, like if you have a multi-select, there's all this extra logic. But to get a value, it's mostly calling the lower level library, like CanJS's can attr get, which given an element and an attribute name, will say, hey, is this normally an attribute? If it is, I'm going to read it as an attribute. Otherwise, if it's like something like value, and I'm on an input element, I'll just get the value of the input element. And some things need to bind to two different events. Like if you're listening to, if you have a, what is it when you can change an element's HTML? What's that called again? Where you set a property on it and it.
Content editable. Content editable, thank you. Content editable, you need to bind to both blur and change events to know when the content has actually changed. So this compute will listen on both of those event types and call the compute's updater function. And we make sure we unbind correctly as well. So this is how you essentially, if you want to compute that is cross-bound to an element's property, this is that version, right? This is a version that does that pretty well. So this compute from is really nice because it like kind of, everything takes the same arguments. So the code, depending on whether we're listening to, where did that go? It doesn't really matter if we're listening to scopes or elements or view models. The signature is the same, so we just get our parent compute and our child compute. Which is cool, not really knowing what type of compute they are because of this kind of factory-ish way of we're doing it, or I don't know what you call this, but it's nice. Then we say, hey, if the parent should update the child, we call this bind parent to child method and pass it the parent compute and the child compute, and we'll see what this does in a second. I think this is right up above. Okay, here's bind parent to child. So what this does is it makes a function that's going to update the child. This could really be called child compute, but it doesn't necessarily have to be a compute. It could just be a function that updates the child. But I think it used to be able to do that, but I think now it's always just a compute function. Essentially what this does is make sure that the parent is actually a compute. And if it is, we're going to bind this update child. And what this does is anytime the parent changed and we're going to update the child, we're going to increment that binding semaphore. And then after every kind of batched event is done, we're going to decrease it. And the reason is because when you bind a child to a parent, we actually won't do anything if binding semaphore is not 0. This prevents cycles. And there's some other logic in here, mostly because this in here is mostly just because of legacy can value behavior that was needed, which I don't want to go into.
Would you mind explaining how the semaphore works? So it's going to know not to update it because the semaphore is 1.
Yeah, or higher.
So it's always going to. Well, why would it be higher?
Well, because you could have the parent change twice within the same batch before the child event was dispatched.
Okay. So then it's going to increment and it's going to decrement all the way back down to 0.
Yeah.
And then you can update. Okay.
Yeah, exactly. So you can just think of it as like the parent changed and then okay, the child is updating, we just changed the child, then the parent can actually change, but then it just prevents it from changing the child. Essentially it prevents it from updating the parent twice. Children can actually change multiple times, but they can only update the parent once. So if you think about it this way, a child value can change. Your view model can change, which will update the parent. The parent can change, and it will actually try to then update the child again. It's because parents kind of always win in a binding. So back again to this main function, we just bound the parent to the child. And this returns the callback function that you can use to unbind the this binding that was set up. So essentially, sets up a binding function, creates it, binds it, but then returns it so that we can manage the unbinding, which happens, we'll return that to the outer universe here in this OnTearDown, which essentially unbinds any of your internal computes. I'll get to that. So again, we just bound parent to child. Then what we need to do now is, because the view model, this is kind of gets back to component, because the view model might not exist, what we're going to do is create a complete binding callback. That once the view model does exist, well then if the child is going up to the parent to the scope, well now we can actually bind the child to the parent, or listen to the child and update the parent with it, and initialize all values once the view model exists if we need to. So this is kind of what happens after a view model is created. And what we do is say that, hey, if the child is a view model, which means it might not exist yet, we're going to return an object that has a onViewModel method that will be able to complete the binding. And we're going to return what the initial value of the parent scope value really is, so that you can use that to initialize the view model with. Now, if the child isn't a view model, then we can actually complete the binding now and return some functions that essentially allow the person to listen to when the element is being torn down and call the OnTearDown method, which undoes all the bindings. So with that, essentially, we get that data binding result back. We check if there is a view model, if it gave us an onViewModel method. If it does, well, we call that, and then we set up, for if this element was removed, we set it up to call the teardown to undo all the bindings. Any questions? Okay, so
Wait, sorry, where is onViewModel created?
onViewModel is really that on. It's named something different in the function we were just looking at. It's the onComplete binding. Where'd it go? By info. Where is it? It's complete binding is really what we're calling onViewModel. So this gets created to kind of finish the child to parent binding and initialize values. So any questions? So I kind of want to talk about how components work, because most of the time you won't actually be seeing anything going on in this data method. Instead, you'll be seeing this view model method that can component calls now. And I'll probably be doing a talk on can component at some point. So can component now, can component, I don't want to, there's some kind of tricky performance things here. I could have, but I chose not to, for every single data binding individual attribute essentially, bound to when this element is torn down and undid the binding at that point. That would have been kind of slow, because then for every single attribute, I'd have to be setting up, every single attribute on a component, I'd have to be setting up a binding on the DOM, which is not very fast. So can component wants to avoid that and kind of had its own teardown functions array, where you just put functions in that should be called whenever the component's element is removed. But I guess I'm kind of getting speaking past where I should be speaking. Essentially, what can component does is call can view bindings behaviors view model, that view model function, and with the element and with some the scope and things like that, and then with a function that produces the actual view model that, when called, takes the initial view model data as just an object of values, and then needs to return the actual view model instance. And then the bindings will be completed, all of the individual bindings will be completed kind of by this view model function. So let me try to explain that. So essentially what's happening is for every single attribute on the component, we're going to go through and call make data binding, just like we did for the one attribute below. And as long as this returns something, we're going to store all the onViewModel methods in this like viewModels array here. So we're just checking, hey, if someone has an onViewModel, we're going to save the initial value from the parent on our initial viewModel data, and we're going to save a callback to be able to complete that binding. And we're also going to save any teardowns that we need to do. Then, once we've essentially done the first half of all of the bindings on the component, then I'm going to call the method the component gave us, which is makeViewModel. The component passed us that method called makeViewModel, where I'm going to pass the initial viewModel data to. And then that's the component getting the initial data and essentially creating a new instance. I think that's mostly right here, a new instance of the viewModel you supplied to your component. And then returning that. So that we save as the viewModel. And then we have all those viewModel on completing the binding methods that we got back. I'm going to go through and call them so all the, essentially all the bindings are complete. And then there's one final bit. Now canComponent is able to listen to when like the attributes change, and essentially all this is doing is tearing down the old binding for that one attribute that changed and creating a new binding again for whenever any attribute changes its value. So what do I mean by this? Who knows what I'm actually talking about here? Like what functionally causes this attributes to change? And how could you use it?
You could conditionally.
Not Matthew.
Sorry.
That's all right. Mikhail, you and I actually talked about this today.
What?
You guys should be asking more questions if I'm losing you. But Mikhail, I actually showed you an example of how this would be useful today.
I'm not sure. Right now.
All right. I'm gonna go down the line then. Pick on you guys a little bit then. Ryan, have any idea? No? Got a good question that maybe you could get towards an idea?
Well, I mean, like, what is it exactly that you're asking, I guess?
Okay, so you see how I'm listening to an attributes change?
Mm-hmm.
This gets called whenever an attribute, like, this is kind of like, you know how you can listen to in like DOM mutation events?
Yep.
This is kind of the same thing. I'm listening to when an attribute actually mutates on an element, specifically on a canComponent. And when it mutates, I'm essentially redoing that binding. Why and where could this be useful? Why is this useful?
Why is the teardown and setup useful?
Yeah.
Or,
What syntactically could you? Where would this potentially be useful?
So,
This
I
is
mean,
this is
besides binding to attributes,
well, it does bind to attributes. That's true if that's what well, I don't know what you mean by that necessarily, but like with bindings, you can bind a component to an attribute value.
right?
Right? Meaning, like, if I do something like this, if I do that, actually foo in the view model gets set to bar.
That makes sense.
And if the attribute changes, if suddenly like some were to go in manually and set set the actual foo property, or the foo attribute to Z or something, this would work, right? It would update. Then foo in the view model would be set to Z instead of bar.
Okay. It's not the value Z, the property Z.
No, the value
Like-
Z.
Where bar is not the string bar. It's
Oh, you're right. I did this
bar.
wrong. Wait, how am I supposed to, sorry, I did this wrong. My mistake. I did this wrong. I was supposed to go like that. And this was set. No, wait, I'm confused now. Hold on.
Just they're talking about that case where you could have a magical.
Yes, I am talking about that case, Mikhail.
Okay.
But I forgot how to set this up in the.
Yeah, one-way binding from the foo DOM element to the bar scope value.
No, I don't want it to the scope though. I want the view model. Wait, is that just wait? It just maybe it's just. Oh, maybe is it just this? Come on. Now I've confused myself. I have to remember. There's a way to listen to just attributes, right? But I think that just happens by default on a CAN component, right?
Mhm.
Okay. I have to check. But yes, Mikhail, what I was getting to is that for bindings you can program now. Meaning, if you have with stash, meaning if you have, let's say I wanted a binding, or like let's say I had a binding and I wanted to do, I want my view model's name property to be, I can actually put stash in here to say like scope name property or something, scope prop name. And what will happen is stash is going to change. If in the scope prop name is, let's say, first, stash is going to update this to say first, and then name in the view model is going to be first.
You could also
It's a way to like templatize your bindings you can do now.
you can also wrap the entire thing in like a if or something, right?
Yeah, so you could do something like this. Is like, yeah, this is really nice for. you could do something like, if something is complete, only then do we want to say, what would be an example? Only if this task is complete do we want to like pass in the user's name for some reason. I don't know.
Yeah, I can't think of any reason to use either of these features.
But people
Yeah, I know.
requested them and apparently use it. I think it's useful when you have like you're looping through a grid kind of thing. Where we're saying like, okay, for the first row, I want to loop through columns and rows, and for every column, I want like this binding name to be. It's first is the first column, so I want to be able to pass the first property to every component or something. I think that's where it's most useful. Anyways, that's why. Anyways, this is why that logic is here. So we listen to an attributes change, and we're able to actually dynamically update the bindings themselves. Cool. So that's it for the most part on the bindings. I'm not going to talk about the event bindings because they're actually much more simple and straightforward. Any questions before I move on to scope real quick? Anything anybody wants to see before I move on?
Real quick,
Really explain.
this you explained one time that you know how web components have a content tag with a select attribute.
Yeah.
Does kind of like what you've been going over, kind of you described how like it's very, very difficult to do if you have kind of bindings going on in that select attribute, like conditional selecting and so forth. You said we haven't implemented it yet. Does this kind of shed light onto why, like all this kind of complexity that's going on here?
So no.
If not, then don't go down that.
What?
If not, then don't go down that route.
So to me, actually, okay. So having dealt with view bindings, actually, to me, the complexity here is actually it's radically simplified compared to what this code used to look like, because it's mostly, you know, to recap it all again, it's you essentially get that object back that tells you all the information about your binding. Then you create a compute for the parent binding and a compute from the child binding. You bind the parent, which is probably the scope, to the child, so it updates the child. And then we essentially we pass a callback that needs to get called once the view model is created. And then once the view model is created, we listen to the child and make sure we update the parent, and that's pretty much it. Like it's weird, I think, because there's like weird, because can component needs to have, it would actually be ridiculously simple if it wasn't for can component needing to initialize its values. You wouldn't have to have this kind of like halfway in between. Well, start the binding but don't finish, and then at the end, once the view model is created, now you can finish the child to parent.
Okay.
But so I actually think it's pretty simple, but it doesn't really relate to that because that's a problem with, I mean, you might say there's similarities because you need to listen to when like the DOM is updated and then kind of recalculate everything. So I guess in that respect, there's similarities because I need to listen to whenever attributes change and re-update everything, like re-update the binding. Content select is the same kind of thing where like a new content select tag just suddenly showed up. You need to essentially reapply every template again.
Okay. It's not directly the same.
Yeah, similar in concept that like on a DOM modification, a lot of things have to be redone. But but the other one's maybe a much more complex example of that. This is actually relatively, like this is not so bad because all I'm doing is just tearing down whatever that binding was for the attribute before and remaking it. Not too bad, where it'd be much worse for other things. Anything else before I do stash real quick? I don't want to take up too much time.
Real quick, Justin, if you can go back to your other file, the one to the left of that one. Yeah. So in this case, if whenever that component was first created,
which case are you
at the very top, very top line you have, you know, where you have it wrapped in the if up there. So say if it weren't completed whenever it was created, like complete was false, then that binding would not be set up, and then it was created, and then it was complete, like that value complete changed to true, then it would be created, and then what would happen if it went back to complete false again? Would that binding get torn down?
So the binding does get torn down, but does username get removed? I don't know. I think I originally was going to have it. I forgot what it does, and I need to maybe look at. So for instance, the use case that someone actually wanted this for was I could have a custom. Let's say I wanted to make a custom HTML-driven checkbox. And I wanted to make checked work here. And the way to make your view model for this is the HTML bool. Hopefully a few of you have seen that. The HTML bool type. The HTML bool type basically means that if what this does when checked is added here, what this does is adds truthy to the. It essentially does. It sets a checked property on the view model internally. It's doing something like viewModel.atter checked is an empty string. Because that will be the value of a checked property or a checked attribute that isn't given anything on the right of it. The HTML bool says, well, empty string is truthy, so type course empty string to truthy, null and undefined are falsy. So I made it so that this works. I know that this works so that if you write something like this, when the checked attribute is removed, this will become false, and when it's added back, it becomes true when complete. Now, what to do with this? That's not, some actual binding. I don't know actually what happens there, and I should probably write, at least see what's happening and document it. And if it's wrong, kind of come up with it. I could see two things. One is I could see, well, we're going to actually remove the foo bar property. We're going to try to call remove attribute if this goes away. The other thing, which I think which happens right now, is simply the binding just disappears. Whatever foo bar was in the scope is just going to be left to that. But if the scope changes, like if Z is changing the scope, foo bar isn't going to be updated.
Should probably call remove adder.
Yeah, that's what I was thinking. That's what the other version does when it's just complete. But I don't know if this should remove the attribute, because let's say you had a two-way binding, or let's say you had a child-to-parent binding, is even more like where you probably wouldn't want to be doing that. Like if you had something like this just might mean, hey, I don't really want to be updating Z with the value in my checkbox, but it doesn't necessarily mean that my checkbox wants foo bar to disappear. So I think the behavior right now is probably the right one. It's just there's no more binding. If you wanted the value to disappear, you should probably be doing it like, I don't know, I have to think about that. Interesting cases. So hopefully that gave you at least some idea of how bindings work. Basically, you're wiring up two computes that talk to each other. So now a quick look into, actually I think we'll end it here, and I'll talk about scope maybe next week, because I don't want to take more than an hour of everybody's time. Anything else? Matthew, you can ask questions now too if you want to.
I don't think I have any.
Okay. Cool. All right. Thanks everybody for coming.
Thanks, Justin.
Thanks.
Actually learned something. Okay, thanks. Bye.